Okay, for a 14.2 on your own, you're welcome to do it on your own, or if you need help, be sure to watch the video. Just remember, either way, we always want to know what do the numbers mean and then what do the dots represent. So as we're answering questions, we can make sure we're referring back to the correct part of the information. So number 3 tells us that the dot plot shows the thickness of sheets of cardstock, which is a type of paper. So we're looking at thickness of paper, right? Thickness of the sheets of paper. So these numbers are the thickness. So numbers are the thickness, and the dots then are every time there's a piece of paper with that thickness, they're putting a dot. So a dot is the actual piece of paper. Now, something we also want to remember, if it's asking us about things that are common, then we're looking for how high they go. But if it's asking us about the numbers here, then we want, right? If it's asking about what's the greatest, then we're actually using those numbers on the number line, right? Here's the smallest, here's the biggest, here's the most common, here's the least common. It's going to use that word common if it's asking about how many dots there are. Okay, so this says, what is the least thickness measured? So it doesn't say what's the least common, so we're not going down. We're saying which one is the smallest piece of paper measured. So thickness comes from these numbers. So my answer should be from the number line. So if I actually just cover up the dots, because we don't need those right now, what is the smallest number on the number line? So A, we want to know the smallest number on the number line. And then B asks, what is the greatest thickness? So again, remember, thickness is the numbers. So we're using these numbers to say what was the greatest amount of a paper measured. That's right, greatest goes over, least goes over. If it's asking common, it will go up. So this one says, what is the most common thickness? So I'm answering, my answer is a thickness, so it's a number. And I want the most common, so the one that has the most dots, I can see is this thickness here. So they all used thickness. So we never were really counting dots necessarily, but we used thickness, but we just had to pay attention to greatest, least, most common, least common. Let's go ahead and fill those answers out. Okay, number 4, a group of people is asked to count the number of coins in their pockets or wallets. The number of coins each person has is shown here. So they asked this person, they pulled out like their wallet, they had 7 coins. The next person had 10 coins in their pocket, right? So they're just asking these people, how many coins do you have? So the very first thing we want to do is I can see a 7, so I'm going to put a dot on the 7. Let me get that a little thicker here. So then I have a 10, and I'm just going in order, 2, 2. So go ahead and pause the video and go ahead and finish your dot plot there. Okay, so your dot plot should be done. I put a dot for each of those numbers. So now we need to know, what do these numbers mean, right? These numbers 0 through 10 are the coins. Whoa, now I'm using a really big marker. So how many coins did every person have? And then the dots are representing a person that had the coins. So our dots are the people. And if it's asking about coins, we're using the numbers here. So what is the most common? So remember, most common. So that means go up of coins. So we're looking at the number that has the most dots. So I can actually see 2 of them that have an equal amount of dots. So you should have 2 answers here. So there's 2 that go up the highest. Hey, how many observations are shown? That question means how many people did they ask? How many people did they observe and ask that question to? So how many people are the dots? And we want to know all of them. So we're going to count all of the dots to get C. Hey, D says, what percentage, so when we're done, we need a percentage of people. Ooh, so we're counting people are dots. So we need to count some dots. Have more than 5. So this is not more than 5. 1 is not more than 5. 2 is not. 3 is not. 4 is not. Is 5 more than 5? No. So we're actually counting all of these people have more than 5. So we're counting all the people. 1, 2, 3, 4, 5, 6, 7, 8 people. I feel like I'm missing one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 people out of the total people. So here was 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 people. So 9 out of 18 people. What percent is that? So our percent here, right? Percents are always out of 100. So there's not a nice way to get from 18 to 100, but there is a nice way to go from 18 to 9, right? 9 is half of this. So if I'm going backwards, if I divide by 2, if I take 100 and divide it by 2, that will give me my answer. Hey, E says, again, percentage. So we're going to need to set up our problem of people have less than 7 coins. So we're counting dots are people. What people have less than 7? So here, right, all of these. So I'll let you count all. Oh, I counted 7 as part of that. That is not true. Less than 7. So 7 is not part of that. So this person has less than 7. All of these people have less than 7. So you're going to see how many people have less than 7. And it's out of 18. And we're going to turn that into 100. So if there's not a nice way to get from 18 to that number, we're going to multiply these and divide by 18. So percentages, right, are always out of 100. We counted the people. We counted the dots that were less than 7 out of 18. What percent is that? Hey, number 5. All right, guys. This one is a challenge, but we can do it. I've gotten much better at explaining it. I've talked to some other teachers. I understand it. I'm going to help you understand it. That is our goal here. Okay, so a basketball team tracks the number of 3-point shots. So 3-point shots. And remember, every time they shoot it and they make it, it's worth 3 points, but it's one shot. One shot, 3 points. It makes per game. So, right, they're tracking their shots every game during a season of games, and it's shown here. So here we have this. Here's our 3-point shots. So these right here, 1 through 6, are the shots. So the shots are the numbers. So every time they made a shot, if they made 1, they'd be here. If they made 2, they'd be here. If they made 3, they'd be here. And then it's per game. So each of these basketballs are representing a game. So you really have to understand that to be able to answer these questions. So basketballs are games. When it asks how many shots did they make, we're looking at the numbers here. Hey, in how many games? Okay, so that tells me I'm using basketballs to answer. Did the team score at least 3-point shots? 3 3-pointers, okay? So we have these words at least. That means 3 is the least they made. They could make 4, they could make 5, they could make 6. So we're counting basketballs, right? We're counting all of these basketballs from 3 and over. All of these they made at least 3, at least 3, at least 3, at least 3. So we're not counting them, right? This one, it doesn't matter. They don't have 3 basketballs. That's a game. In this game, they made 6 3-pointers. In this game, they made 5. That's at least 3. So all of these, we're counting the basketballs. Okay, our next one. Trickiest one. We got this. I got it. Okay. How many games? Okay, so at some point, we have to count basketballs. Did the team score exactly 9 points from their shots? Okay, so right, this game, they played a game and they scored 1 3-pointer. In that game, right, so they played one game, scored 1 3-pointer. So a 3-pointer is worth 3 points. So right, here's their 3-pointer. Now they have 3 points. We're trying to get 9 points in a game. So in this game, every time they only scored 1 3-pointer, they only made 3 points. That's not this question. Okay, so let's look at this game here. In this game, they scored 2 shots. So the first one was worth 3, the second one was worth 3. 2 times 3 is 6. So every time, right, in this game they scored 6, in this game they scored 6, in this game they scored 6. The game was not worth 9. That game was only 6 points. So let's try out the next one here. So they made, right, in these games here, this game, they made 3 3-pointers. So 3 3-pointers. 1, 2, 3, 3 points, 3 points, 3 points, 3, 6, 9 points. And that's what we want, is exactly 9 points. So right here, when they score 3 shots, they made 9 points. Now we have to come back to our question. How many games did they do that in? Games are the basketballs. So here's 9 points. How many games did they do that in? Right here. How many games? Okay. So here's 3 3-pointers is 9. 3 3-pointers is 9. So each of these is worth 9. How many times did they do that? Okay. All right. Our next one says, what is the most, right? And it doesn't say most common. It says most, right? So we're using that number line. Which one is the greatest? And we're looking at the shots. Shots are numbers. So I have to use these numbers here on my number line. So let's take away the basketballs for a second. From your number line, which of the shots is the most? Okay? It doesn't say which one has the most. Just which one is the most? What's the biggest number on this number line, right? The farthest to the right is the most. Okay. All right. And our last one, D, what percent? Oh, so we've got to do percent at some point. Of the games did the team score at least 3 3-point shots? Well, right here we said how many 3-point shots they did. We counted, right, all of our 3 or more, and we came up with 11. Hopefully you came up with 11. So telling you number or letter A if you weren't paying attention. So now out of how many total? So here was 11, 12, 13, 14, 15, 16. So out of 16, they did 11 out of 16 games had 3 or more 3-pointers. We need to make that out of 100. So looking at patterns, there's not a nice way to go from 16 to 11. And there's not a nice way to go, 16 to 100. And there's not a nice way to go from 16 to 11. So we're going to multiply, which is 11 with 2 zeros. And I'm going to divide that by 16. I can tell you it is going to have 2 decimal places here. So something above each of those numbers. So go ahead and figure that one out. So understanding shots versus dots, or the shots versus the game, can really help you break apart the question. Write down, what do you know? Okay, and our last one is going to feel pretty easy compared to the one we just did, so that's good news. Okay, the weights of a set of gemstones a jeweler has for jewelry are listed. So here's their weights, and here's all of the gemstones. So the very first thing we're going to do is make a number line. We have to put these in order, so we need to look for the lowest ones. 2 tenths, 5 tenths, 1 tenth. They're all tenths, so our lowest one is 1 tenth. And it looks like I've got 6 tenths. Oh, here's 7 tenths. Are there any 8s? So we need to go, right? 2 tenths, 3 tenths, 4, 5, 6, 7 tenths. So make sure you have filled in all of those to make your number line. We want to go in order so that it makes sense to the person looking at it. So now I'm just going to take these and put a dot. So I have 2 tenths and then 5 tenths. So go ahead and pause the video and get your dot plot made, and then come back if you need help answering the questions. Okay, so we have our dot plot made, so we need to know, what are these numbers? The numbers, right, are how much they weigh, and every dot was a gemstone, so a gem. So if it's asking about gems, we're counting the dots. If it's asking about weight and how much they weighed, we're using these numbers at the bottom here. So how many observations, right? That's just meaning how many students or how many people or things were they looking at. So we're talking about the gems here. So how many gems are there? Okay, what is the most common size, right? So that's their weight. So we need to give an answer from the number line this time. The most common, remember, most common is the one that goes up the highest. So the weight that goes up the highest. So not the greatest weight, which one just has the most. And then this one, again, asks the weight. So we need to use a number from the number line that is the least common. So which gemstone has the least amount of those? So we're looking for the one with the least amount of dots for D. So go ahead and finish those up. And if you still need help with the basketball question, I'm so happy to help you, because I promise I got really confused on it the first time I did it too, and had to go ask another teacher for help. So it is okay to ask for help. You just have to do it.